Good day, grade 7. Today we are going to look at a natural sciences paper. So it's 60 marks and the duration is 1.5 hours. So without much further ado, we're going to look at the multiple choice questions, right? So number one, reads the kinetic energy is more of us defining what kinetic energy is. So kinetic energy is defined as the energy an object possesses due to its motion or movement. So let's look at the answers there. Stored energy is incorrect. Then movement energy, this is what we refer to as kinetic energy. So our correct answer is B. Wasted and chemical energy are also incorrect. Moving to 1.2 says heat always travels from, right? So heat will always travel from a hot environment to a cold or a cold substance. So from hot to cold. So our correct answer there is going to be C, so that it can actually spread out evenly. So it's going to start from a hot area to a cold area. Then the north and south, these are the poles. These are the poles, they've got nothing to do with this. So this one says cold to hot. Our heat always moves from the hot area to a cold area. Then 1.3 says plastic can be used as, so plastic can be used as, let's look at our options there. Insulator, I will circle this one. Then a conductor, a plastic does not conduct electricity. Then a fireproof vest, it cannot be a fireproof vest because it can easily bend there. A chainsaw is also incorrect. So our correct option there is an insulator. Then moving on to 1.4, reads there, an electric bulb is an example of, so an electric bulb, the lights that we use at house there, so they give out light. Therefore, if they're giving out light, once you switch them on, it means they act as an output device. So let's look at our option A. It says input device is incorrect. A storage device, it doesn't store anything. A circuit breaker is not a circuit breaker. Then D says there an output device. Yes, it's going to be an output device because it gives out light. Then moving on to 1.5 there, reads heat conduction happens in solids, liquids, gases, and then D also gases and liquids there, right? So our option there is going to be what? Conduction, right? So to conduct, here we looking for what? For solids. Then here liquids is a different type of what? Of conversion currents, and then also we're having our gases there. They are going to be incorrect. So our correct option there is going to be solids only. Moving on to 2.1 reads there, which type of energy uses the sun to generate electrical energy? So which type of energy uses the sun, right, to generate electrical energy? So we use our solar energy. So for sun there, we're using our solar energy. So solar energy is uses sun to generate what? Electricity. Then 2.2 there reads, what is a non-renewable energy? Non-renewable energy. So this is energy that is used up. Energy is non-renewable. Energy that is used up, faster than it can be replaced. Right, so there we can have our examples such as coal and stuff, right? So use the diagram to answer some questions that follow. So we're given here a wrecking ball. So it's a wrecking ball there. Then they're saying from the picture, what type of energy is represented by the wrecking ball, right? So if we're to move it back, we're going to have, like, maybe we lift it above the ground, we're going to have what we refer to as potential energy. So I'm going to say there for 2.3.1, 2.3.1, I'm going to say it has got potential energy, right? Once you pull it back and then above the ground, there is going to have potential energy. Then if the ball is moving, it can be a potential energy, right? So I'm going to say it has got what? Potential energy. Once it starts to move, right? So let's say this is our wall there, then we move it maybe to here and then leave it there like that, right? So as it's hanging there, it has got what we refer to as what? Our potential energy. Then once it starts moving towards this wall there, so when there is movement, now we have what we refer to as our EK, which is our kinetic energy. Then 2.3.2 says, how is the wrecking ball able to break down the wall, right? So I'm going to say 2.3.2, right? So if we were to go for this position there, right? So it has got potential energy. Once it starts to swing towards the wall, once it starts to move there, now that's where you're going to have what? Our kinetic energy. And that kinetic energy is going to be used to bump into the wall and then wreck it down, right? So I'm going to say the wrecking ball has to be lifted, uh, and moved towards the wall. So if you are to lift it like this away from the wall, right? So once you let it go from this position, it will swing towards the wall and then it will bump into the wall and then demolish what? This wall or break it down. Then 2.3.3 says, at what position highest or lowest will be the ball be able to break down the wall and why, right? So as its highest, so our answer there, we're going to say highest. Then we're going to explain that the ball will have more potential energy. So our reason for 2.3.3 there, we're going to say the ball will have more potential energy. Remember, potential energy is stored energy due to the object's position above the Earth's surface, right? Potential energy, which will enable it to break down the wall. It to break down the wall. Like that, right? So we're done with question 2.3.3. Now moving on to question number 3. Says heat transfer and electrical circuits, right? So now we're having a thermal conductor, thermal heat or conductivity there. So we're given different materials there. We've got our iron, tungsten, platinum, aluminum, silver, copper, and then we're given a temperature there. The first one is 25, then it increases to 125, and then lastly it increases to 225 there. So it says which material was a good conductor of heat at 25 degrees, right? So now we want to see how much heat can it absorb at 25 degrees, right? So we're going to look at this column there for 25 degrees, right? So now which one has got the highest temperature there? We can see that our silver there is the one that has got what? Highest temperature. So it means it was a good conductor of heat at 25 degrees. So our answer there is going to be silver. Then moving on to the next one, it says discuss the thermal conductivity of copper as temperature changes, right? The thermal conductivity of copper as the temperature changes, right? So we need to look at what was happening at 25 degrees, then also at 125 and then 225, right? So you can see instead of it increasing here, the temperature is actually what the conductivity is what is decreasing, right? So we're going to say there decreases is conductivity decreases, okay? It decreases as the temperature increases. So it decreases as the temperature increases. Temperature increases like that. Okay, then we move on to question 3.3, which reads, explain the thermal heat conductivity of iron and silver at different temperatures, right? So we're going to look at iron and silver. So this is our iron there. And then maybe just let me highlight there. This is our iron there and our silver. So we're going to look at these values there, right? As temperature at different what temperatures, right? So these are the different what positions there given at what the different what temperatures, right? So we're going to look at those values there, right? So now I'm going to say here at different temperatures, what actually happens is that the thermal conductivity of the two metals decreases as temperature increases, right? You can see at 25 it was 80, then at 125 is now 68, and then at 225 is 60. So there is a decrease there. Their conductivity decreases. Same applies with one for silver, which was 420, now it's 418, then 415 there. So the general trend there, we can say the temperature, the thermal conductivity, the thermal conductivity, the thermal conductivity, thermal conductivity, thermal conductivity uh, of these two metals, of the two metals, what happens to them? Decreases. Okay, so our answer is decreases as temperature increases, like that. Okay, then moving on to the next question there, 3.4. It says, which metal is the best conductor of heat in the table, right? So which metal is the best conductor of it in the table, right? So now we can see the one with the highest value is silver there. So our best metal conductor there is going to be silver. So our answer there, we're going to retain silver again there. So now moving on to the next one. 3.5 says here, study the diagram shown, right? So we're given a diagram then. 3.6.1 says, what makes one circuit diagram not to work out, right? So if we are to study these ones there, we're having a metal. Remember, a metal is a conductor of what? Of electricity. But on this other one here, you can see we're having our ceramic there. So this one does not conduct electricity there. So what makes one circuit not to work out? So it means now this one here, the first one there, you can see the bulb is not on there, right? It's not burning. And then this other one is burning what? Bright there, right? So you can see all these electrons, they are moving like that. So on this one here is actually like not burning. So it's not on. What makes it not on, right, is because of this what? A ceramic there, which is a more of a what? An insulator. So now I'm going to say it has an insulator. It has an insulator, right? So which insulator there do we have there? Is ceramic, like that. Moving on to 3.6.2, it says, by referring to the diagram shown, explain the difference. Okay, so we're supposed to explain the difference between a conductor and an insulator. So what are the major differences between a conductor and an insulator? So now I'm going to say a conductor allows, so a conductor, I'm going to say a conductor allows electric current to pass through it, through it. Whereas an insulator does not. So these are the differences between what? A conductor and an insulator. Then we're going to proceed to question number 4. It says here, what do you think is the aim of this what? Investigation, right? So now we're given something like this. There is water there. We see our thermometer there. Then we also have our stopwatch there. Then here we've got like no insulator. Then here, what they did here, they placed a cardboard. Then here they said a bubble or wrap, right? So around that same beaker there, right? So it means there is water inside. Then here they put a cardboard around it. Then here, what they do? They put a bubble wrap around it. Then heat-proof masks met then, and then thermometer lid, right? So now we can see now we are having different readings there, or in terms of these what? Thermometers, right? So now they are asking us, what do you think is the aim of this investigation, right? So now the answer there of this aim is to investigate. Okay, so I'm going to say here to investigate. So question 4.1 there, 4.1, I'm going to answer it and say to investigate which material is a good conductor, like that. Okay, then moving on to 4.2. So you can see here we've got different materials there, right? So we have got like a bubble wrap, cardboard, and then the other one has got no what? Insulator. Then moving on to after how long were the readings taken, right? So now we can see the readings were taken for 3 minutes, right? So we're given that time there. That's our stopwatch there. We're going to say the readings were taken for what? For 3 minutes. So we're going to say our answer there is 3 minutes, like that. Okay. Then moving on to 4.3. So 4.3 says, why do you think the lowest temperature was recorded in A, right? So you can see A has the lowest temperature, while C has got the highest temperature there, right? So now, what's the reason behind, right? So I'm going to say for 4.3, it is because it is because A has no material that prevents the loss of heat, right? So now I can just say in brackets the insulator, right? So it has no insulator, it has got no insulator, like that, right? So if you can look at here, it says no insulator. A has no insulator. So if you write, say A, no insulator, you are going to be correct. Then moving on to 4.4. 4.4 says use the diagram to answer some of the questions that follow. So now we've got our hits, we've got our sound there. This is a drill check, check, drill, then cover drill, right? So we've got two drills there, right? So we've got the electrical energy input, right, is 100 joules, and then the other one has got an electrical input of 120. Then here useful energy at the end of our drill there, right? So now we've got our heat and then our sound, also heat and sound there. Then I'm going to move on to question 5.1 according to that. So I'm going to say 4.5.1 there. Okay. So now okay. Then in what form is heat wasted by the drill? In what form is heat wasted by the drill? Right. So in terms of that, the 4.5.1 says in what form is heat wasted by the drill, right? So now, what form there? If we can look at these ones, right? So we've got our heat and what? And sound, right? So I'm going to say the answer there is heat and also sound, right? So there, like that. So we have got the heat and the sound. If you can look at this, our aim there is our useful energy there, right? To drill maybe the wall, but this comes as heat. We do not need heat, and also sound. We do not need it, but they are part of this whole drilling process, right? So we are focusing what we need is useful energy there, the drilling part. Then this one comes as we are drilling. So it's going to considered being as what? Wasted energy there, right? So now how much energy is wasted by the jack drill, right? So the jack drill, we've got this and that, right? So I'm going to say how many there? I'm going to say 4,5,2, right? So what we have there is going to be 15 plus 10, right? So a total of how many there? 25 joules is wasted by that jack, right? So now I'm going to proceed to question 4.5.3. So 4.5.3 says how much is useful energy in Kawe drill, right? Kawe drill has got this there, right? So we started with 120 there. So I'm going to say 4,5,3 there, 4,5,3. So we started with 120, right? So that's 120 there. How much did we subtract, right? So we're going to subtract this heat and what our sound. So if we are add 25 plus 10, we're going to get a value of what? 35 joules, right? So we are supposed to say 120 minus 35 there. So we're going to get a value of what? If you calculate, we're going to get an answer of what? 85 joules there. So our answer there is going to be what? 85 joules. So this is our useful energy, which is 85 joules there, right? So we're done with question 4.5.3. So that's our section A, which has a total of 36 marks. Now we're moving on to section B, right? So it says the solar system and movements of the earth and what? And planets there, right? So it says use the diagram to answer some of the questions that follow, right? So we've got this axial tilt there, the North Pole, and then the South Pole there. So there's the South Pole and then the North Pole, and also we're having our equator there. there, right? So the tilt there at the angle there, here is usually an angle of how many degrees of 23.5, right? 23.5 degrees, right? So now to proceed to say there, how long does it take the Earth to make one spin on its axis, right? To make the spin on its what? On its axis there, right? So how long does it take, right? So I'm going to say it takes how many hours? It takes, yes, how long is a day? A day is 24 hours, right? So it takes 24 hours, right? So by what angle is the earth tilted, right? So that tilt there, I already mentioned it. It tilts at an angle of 23.5 degrees, right? Then moving on, it says, explain why the nights are longer in winter than in summer. So why is it that we have got longer nights in winter than in summer, right? So the nights are longer because the nights are longer. I'm going to say the nights are longer. The nights are longer because the sun is tilted away from the earth. The sun is tilted away from the earth. So I'm going to put it at the top there in what? In winter. Like that. Okay. Then we move on to 5.4. It says in the southern hemisphere. So in the southern hemisphere, they have the equinox on the 20th of March, right? And 22nd of September, respectively. What is an equinox, right? So we are asked to define what an equinox is, right? So equinox, equinox, right? Like that is the day on which is the day on which the the day or is the day on which the day and night are the same length. The same length. So it means now we have got equal day as well as what? Night in terms of the what of the hours. So that's our equinox is the day on which the day and night are the same length, right? Then moving on to question number 6, it says here, question number 6, relationship of the sun and the earth, right? So relationship of the sun and the earth, and then we're asked to use the diagram so to answer some of these questions that follow, right? So we can see plants dying in swamp forming a pit, then pit is compressed to form sediments and lignites, then more compression to form bituminous and subbituminous, then more compression leads to formation of anthracite, height, a black coal, right, which is our black coal. Then coal gas and oil is formed, right? You can say I've got coal there, we've got oil, and then we also have our natural what gas there. So now they're saying give one energy source that formed from dead organisms over millions of years, right? So now we're going to take all these there as our answers, right? So just need one there. So you can say it's your natural gas, or you can proceed to say it's oil, or you can produce to say what is coal, like that, right? So natural gas, oil, or coal, right? Just coal, just one there is going to be correct. Then how does the heat travel from the sun, right? So it travels through radiation, is through radiation, right? So that's how heat travels through the sun, right? Heat energy travels from the sun to the earth is through radiation, right? Then 6.3 says discuss how coal is formed, right? So I'm going to say coal is formed. Coal is formed from carbon rich. Okay, from carbon rich giant plants. I'm going to say giant plants there. Okay, so you can see at the top there, right? Like that, right? From giants, plants, and any animals that died and decayed, and decayed, decayed, uh, over time, over time, over time. So coal is formed from carbon-rich giant plants and animals that died and decayed over time and changed due to heat and pressure into coal. Right, like that. So it's more of like following these steps there until you get to the final process where you're going to have your coal and gas and oil being formed. Then moving on to say what puts the consumption of natural gas resources at risk. Right. What puts this one? Then okay, so the reason why is that it takes millions of years for them to be formed, right? So it takes a very long period of time, right? So I'm going to say coal, crude oil. I'm going to say coal, okay, oil. I will say oil and natural gas. Natural gas. What happens to them? Do not form at the speed, at the speed at the speed they are being consumed, at the speed they are being consumed. So that's our answer there. Then moving on to question number 7. So question number 7, it says the movement of the moon. So it's the movement of the moon and the relationship of the earth to the moon, right? So what's the relationship between the earth and the movement of the of the moon there, right? So use the diagram to answer some of these questions that follow, right? So we have got the moon that is actually rotating like that, right? So and then we also have our sun like that, right? So this is our earth and then the moon at the top and then this is the sun there. So we are asked to define what a moon is. So what is a moon? Right, so a moon is a natural satellite. So it is a natural natural satellite that moves around the planet. That moves around the planet like that. Okay. Then moving on to question 7.4 says discuss the effect of the moon's gravity on the bodies of water. So the effect of gravity of the moon's gravity results in the formation of Of tides, right? So it results, I can say the effect, maybe the effect of the moon of the gravity of uh, the moon's gravity, okay, then in the results in the formation of of tides like that, right? So that's our answer there for 7.4, right? Then moving on to 7.5, they're saying use the diagram to answer some of the questions that follow. Therefore, we're having the sun there, we're given the sun, the new moon, how it actually rotates and stuff. So we've got a spring tide, the first quarter moon, the nip tide, full moon, spring tide, a third quarter moon, and then a nip tide, right? So as it actually rotates there, right? So what are tides? So these are the periodic rise and fall. So I'm going to say tides, the periodic rise and fall, periodic rise and fall of large bodies of what? Of water. That's a tide. Then mention two factors causing tides, right? So I'm going to say the moon. One is going to be the moon. Then the second one, I'm going to say the rotation of the earth. The rotation of the earth. like that, right? So if I can also add maybe the gravitational pull of the earth, you can so also say the gravitational pull of the earth. Then moving on to question 7.5.3. So 7.5.3 says explain the difference between high tides, which are spring tides, and low tides, which are referred to as our nip tides, right? So now I'm going to say in terms of this, what I'm going to have there, I'm going to say high tides are formed, okay? So I'm going to say high tides are formed when the sun and moon, when the sun and moon are in a straight line, in a straight, in a straight line, whereas nip, okay, whereas nip or low tides, right? Nip tides, I can just say nip tides or low tides are formed formed when, allow me to continue at the bottom there, are formed when the sun and the moon, when the sun and moon are at an angle, are at an angle, or during what's, or I can just say during quarter moons, quarter moons. Like that. Then moving on to question 7.5.5 there. 7.5.5 reads there, by referring to the diagram, when do we experience high tides and low tides, right? So we experience this one. High tides are formed during this full moon, right? So we experience here whenever it's full moon. So here, whenever it's full moon, we're experiencing what we're going to refer to as what? High tides, right? And then also now, when the moon and the sun are aligned, right? So whereas the moon and the earth are aligned, right? So that's where we're going to have like our high tides, whereas low tides occur during the quarter moon, right? So now I'm going to say, where do we have a quarter moon? We're having here a quarter moon there. That's where we're going to have our what? Our nip tides, right? So I'm going to say here, what do we have there? We're going to have our nip tides or low tides, right? So, or low tides. Then here is our high tides, like that, right? So now this is how we're supposed to answer these questions, right? So with that being said, thank you all for watching. Hope you enjoyed the video.